Hello everybody, my name is Tim and welcome back to Astro Addict. The last image of the Pleiades turned out to be quite popular, let's say, and that's why I decided to do a tutorial on how I edited this image. I've been using two different kinds of software for this image. First of all, for calibration and stacking I've been using Astropixel Processor, and for the final processing after the stacking I used PixInsight. I'm already hearing some of you scream why I'm not using PixInsight only for every image. I don't have a full grasp on it yet, let's say. I still need to figure some things out, and while I have APP does almost everything on its own and does it good. I feel that I can reach almost 95% of the PixInsight quality with APP, and I need to do almost nothing, so that's great. That's great. And the most important thing, usually I share my imaging data on my Patreon page, but for this one I decided to share it with everyone. So if you want to follow this along, if you have APP, if you have PixInsight, I know they are quite expensive, let's say, but if you are seriously getting into astrophotography, I can only recommend them. They are very powerful, and even if it's only the classy way of Deep Sky Stacker and Photoshop, you can do that too. I will link all the imaging data down below: light frames, flat frames, darks and bias. Individual frames, they are the fit files of the ASI camera. And if you want to use them in Deep Sky Stacker, you have to debayer them first in the settings menu. And of course DSS will do the rest for you. So that's great. Alright, let's get started. You can see I'm here in Astropixel Processor. The first thing I need to do, the color frame array is of course an RGB, a basic Bayer pattern of the camera. I need to force this value because APP has some problems detecting the Bayer pattern of the ZWO camera, but that's all taken care of now. Let's load in our frames. We have only one filter and one session, so nothing to change there. Masters integrations. Now let's load our light frames. I will have to go to the hard drive here, Astrophotography, Pleiades. You can see already the previous intermediate files. Light frames. Now these frames I will put up, they are already sorted out, so there are no bad frames in there. You can see a bit of moon glow, but I sorted bad satellite trails out, bad trailing of stars, and even the power cable that went across the house and interfered with, I think, 5 images. So these images are already cleaned out. I believe it's 93 light frames. It is. Next up, the flat frames. And you can already see I tried the Deep Sky Stacker method, it didn't really work for me. Flat frames. Dark frames, now we have to go to the calibration folder, library. I'm really glad I kept those darks so I can upload them for everybody. Darks 120 seconds at minus 20 degrees. I don't have dark flats, which taking dark flats over bias or only bias frames is a very heated discussion in the Astro forums, but I tend to stick with bias frames. Alright. Calibration. I like to use the outlier rejection method of the Windsor clip for most of these. I will not change many values. Dark flat, I don't even have those. Master flat, Windsor. I will not detect bad columns because the ASI doesn't have any of those yet. I hope it won't happen. I will not need the rejection map. I will create the bad pixel map. The amp glow is very important for most dedicated cameras. Let's reduce that one. And I think that's about it over here. Analyze stars is just the basic routine, registering. I think everything's fine in here too. I will not do a distortion correction. Normalization, I think most of these values are fine. I will neutralize the background. I will have to use the tool, what's it called? The calibrate background tool at the end. I will do that, of course. Don't need to save them. I will integrate the best, let's say 90%. 83 images. With a weighting. And the weighting is very important. PixInsight has way more options to weight your images. I will go just for quality over here. Now the quality parameter is an average value of the sharpness of the stars, the signal to noise ratio, the background. So basically all these three values are combined, and each image is given a quality value, the first one at the reference image at 100 and going down, and taking a less percentage in of every image to sort the images out that don't add too much good data to everything. I will do the normalization correction, but only a very slight correction. I don't need to blend these images. Windsor clip again, also for the light frames. I don't have diffraction in this image, and I'm really glad I have. I have to say the glass of the Albegan Q is really high quality. I will not drizzle this image, it's no advantage at all. Only choose to drizzle your images if you have undersampled stars and the images are dithered very well. Otherwise you won't get anything out of drizzling. Only an image that is twice as large. Alright, everything is set, and now if I click integrate, it will go through all these steps. Calibration, star analysis, registering, normalizing, and then integrating. So this can take quite some time, and I think I will stop the recording and get back to you as soon as this image is finished. See you in a bit. I think this integration and calibration took now half an hour. Let's look at the result. Let's go down here. On the bottom should be the integration. There it is. How does the master flat look? Pretty good. Integration. Now, what do we have here? The background noise looks alright. The nebulosity is smooth and crisp, I like that. The stars at the edges are still, I don't know what's up with that. I think the telescope is out of collimation, but even those in the bottom right here are slightly drifting to the top right, which is definitely weird, but I got used to it. Let's go to the tools. The first tool, I think, the resize? No, that's not it. The modification. I will crop this image to get rid of the edges at the end where the dithering has picked out some frames. Crop OK. Save it as a fit file. And now grab that fit file over here. Nice. Alright, the next step could be to correct the vignetting or the light pollution. The vignetting is pretty good taken care of, I believe, because we were using flat frames. So let's go to remove light pollution, which is almost equivalent to background neutralization with this tool. So let's draw some boxes of neutral background sky. Gotta check not to choose that many stars. Over here maybe no nebulosity. I will turn up the preview stretch. Alright, you can see that there's definitely a gradient. The right side is much more brighter than the left. Let's choose some more. Not choose any nebulosity. Go back to 15. Yes. Let's see how that looks. Nice. Now the right and the left side are definitely on a better level. Save this one. Background calibration would be an unnecessary step because the calibration is already included in the light pollution correction, but let's do it again just to make sure. Would be a great feature to have these boxes again with the next tool. No difference, as you can see. Alright, the next step would be calibrating the colors. I'm quite unfamiliar with color calibration in PixInsight, that's why I'm doing it in here. I think APP does a decent job. Calibrate star colors. And I'm gonna choose this small chain over here. One of my favorite features of the Pleiades is this. In the green box, the line of stars over there. They look super amazing in the final image. Let's choose some more over here. The group with this bright red one to have some comparison. That's too bright. And these ones. I usually go for balance RGB. Calculate. It's gonna take some time. It's gonna analyze the colors in the boxes. I definitely don't like what it did to the nebulosity there. It's way too blue. The entire image is too blue, as you can see. The brightest parts, the dim nebulosity in here is way too blue. Let's choose a different mode. Can't really remember what I chose the last time. This looks good. Oh, nope. I misclicked. Come here. Color calibration. These ones, this bright, and these. Let's stay with black body extinction. Let's take a look at this method. Come on. Again, way too blue, and I don't like that the red out of this star disappeared into a yellow tint. Let's see. Definitely like this one more. The nebula got a bit more gray, let's say, but I still like it. But the only problem I have is that the star colors are now almost only blue and yellow. Let's go more for a reddish tint and maybe some over this. Let's see. Let's take a closer look at the stars. Didn't really change that much. Let's choose some different stars. I don't think that this works too well. Let's not choose the chain. Let's choose some smaller stars, most of them. I think it got even worse. Great. Yes. I can definitely live with this value right here. I think I can bring back some of the redness in the stars, because having lots of different colors in the stars, not artificial colors but actually true color, which I can hopefully pull out with masking, it's pretty nice. Alright, I can definitely live with this. Save it again. I could go for some hue, saturation and luminance correction. I don't think I want it though right now. Maybe we can bring back some of the color in the stars. Background to 7. No, the stars are bright. 80 over here. Let's get some red in there. But I believe I'm just doing it once. Let's see how this turns out. I think other bright stars are just... didn't change that much, I'm quite surprised. Let's go back to this. How does this look like? To most of the background. Nothing special really. Let's set this... oh, nope. This back to normal. Almost normal at least. I will play with the nebula a bit more. I want this more magenta, a little bit more blue, less cyan. Okay, let's return some of that bluishness. Okay, that's quite good. A little bit too much, maybe actually. Let's turn this one back just a tiny notch. The problem is, once you saw the saturated image, the turned down one, as I did right now, looks always worse. But you have to get used to the fact that the comparison is the best thing. Alright, I can live with this integrated image. I will save it without any stretch, because I think the stretching feature in PixInsight is way better. No stretch, thank you. Let's actually apply the selective colors and create the final file. I always call them something like APP Pleiades. Alright. Now we are in PixInsight. Let's just open... I think I've got on here, projects, Pleiades, this one. All the previous versions are in here too. And also the bad pixel map. It's okay. Nice, this looks promising. I can even see some of the faint nebulosity on the left side here. Let's get started with the PixInsight processing, actually maybe the longest part in this tutorial. I usually start... It may be a bit weird that I'm doing such a video right now while the explaining PixInsight tutorial series is running, but I'm having some issues with that one because the color calibration is a very complicated step and I can't really explain that correctly at this point. So let's do this one right now. Wrong button. The icons, process icons, load. Background modelization. Most of the background is already subtracted, but let's do it again. I will choose the dynamic background extraction tool and place my markers on areas of neutral background sky, maybe we will see a difference. If let's see if PixInsight can draw out a little bit more detail. And the point where I explain this in the tutorial series, I used the how did I call it? The sky survey data. I don't think I want to do this right now for the sake of this tutorial, because it can take a lot of time. Is there really any difference? Actually, yes, there is a difference. I can see more of the faint dust on the right side without any, which does not have any blue color, which always looks weird on Pleiades images if you ask me. The background here got more darker, but I see some yellowish tint up here. Let's do some more marks and hopefully get rid of that. I subtract the background. I got so used to this method that I didn't really explain it, and I'm choosing the extraction tool, and the image correction is subtraction, because we want to get rid of the background, which is additive, and I don't need the background model. Maybe I can just show it once. Actually, it would be good to see why it's creating more yellow over there. Alright, I think this is because I already used APP. I've never seen something like this before. I didn't look at the background model before. Interesting. Yes. This is very good. You see maybe you see the slight green tint now in the, especially in the edges over here, but we can get rid of that very easy. I will continue working with this one and save this one on the corner. I don't need to do anything right now with the background, I suppose. Next step. Deconvolution. I did a lengthy tutorial on deconvolution already. I will therefore not explain it right now. We'll just do the best settings, because this can take a lot of time. Maybe I will actually pause the recording. Bear with me, this can take a lot of time. Or maybe actually I don't think I want the deconvolution right now. If you don't know how to use it correctly yet, I think I got a good grasp of it. It can make things even worse if you don't compare enough the before and after. I will not do it this time. If you want the tutorial on deconvolution, you can look it up. I will link it up here, I think. And we will continue with... We already did the color calibration, I don't need that anymore, but the first part of noise reduction is in here as well. I will choose a preview. This is not good. I will choose a preview where I have decent background and nebulosity. I think this is good enough. Yes. Alright, multiscale linear transform is the first noise reduction tool you do for the linear image, remember? The full image looks like this, and this is the preview stretched version. The layers and scales are the wavelet layers. So doing some noise reduction on the lower layers will not affect the nebula. I will target the luminance channel. The luminance channel is basically all the color channels combined, to explain it in an easy way. Did anything change? Yes, definitely. I can zoom in a bit more. You can see we have the two stars here. Let's go close to one of them to see that the star itself is not affected, but the background is. You can actually I think I missed wrong button, alright. Without width, without width, without width. This looks good. Do I want any noise reduction in the nebula? I don't think so. The noise in here looks amazing. Let's do maybe a tiny bit. Just very, very tiny bit. Undo this, target the luminance again. This change is way more drastic. Do I like it? I actually don't. The nebula is getting damaged. I could use the linear mask to protect. I will create a mask eventually. Alright, these values are fine, just getting the background a bit smoother. Let's go to the main image again and create the mask. To get the best nebulosity, I will actually do a small stretched version. I will explain this when we actually arrive at stretching. Because the range selection works way better on non-linear images, as you can see right here. We don't want any of this to be affected. Great. I think this is a good mask. Maybe fine-tune it a bit more. The stars are protected anyways by the wavelet layers. I think this is fine, and I think it is. We don't need the clone. Bye bye. Apply the mask. And I had to reinstall PixInsight because of some updates, and I really don't like this render mode. Replace. Now white selects and dark protects, so we have to invert this one. I have to remind myself every day, because it can be quite confusing. The mask goes over here. We can use it multiple times if we want to. The mask is there, we just don't show it, and apply. Let's take a look. The noise got smoothed out, and I will once again do it, but target the color channels. So to reduce the color noise in this image. And you can see quite well how the mask works. I actually don't like how it's protecting a larger area around the stars. Let's try it without this one. I think we can do even more. Remove more pixels, increase the threshold. And RGB again. Just getting rid of some of the black in between each color modeling. Alright. The background looks way better now, I think. Next step is the stretching, because the multi-scale linear transform noise reduction tool works best on linear images like this one right now, and after we stretched it, we will also use the TGV denoise. as I edited this image earlier, the last time, I tried the masked stretch. I really have a hard time pronouncing that one. So this stretch basically iterates, it brightens the image and applies a mask to each bright spot to increase the high dynamic range. But I did not like the result because the colors in the stars looked amazing, but the actual bright stars of the cluster looked just way too small, and I like them being very bright to be the main attraction of the image. That's why I usually choose the basic auto stretch of PixInsight. It looks great, in my opinion. I will open up the screen transfer function and the histogram transformation. Reset. Now, this is our linear image. We will stretch it using the transfer function, and now apply this transfer to the histogram. Undo and apply. The mask is still there. Alright, let's remove this mask. Here we go, nice. And I still see some greenish in here, but it's not a problem, not yet. Our image is now non-linear. We can see everything if we save it. The next steps are the most exciting ones, because I used to call them five-way contrast. I now call them finishers, because it's the final touches of the image that are most powerful. All of them on the red side. The first one, I will maybe darken the background if I can. By clicking on the track view, we can see the histogram on the top, and we can alter it a tiny bit. Can I zoom in? That's not a help. Let's go to 5 maybe. Can I zoom in here? Yes, I can. There's no data until maybe this point. So this tiny point over here. Just a tiny change. Getting the background a bit darker. I can now see this worsened the greenish tint, actually. Let's get rid of that one. Let's use the SCNR tool. I forgot what SCNR actually stands for, but it gets rid of even that color in the background. Either red, green or blue. Mostly it's green in most images. And it looks incredible. Let's zoom in. Look at this. This is the nebula color I wanted, and it looks amazing. And the background is awesome. The color calibration really worked well, and I believe I can draw more out of these stars. More color. Do I want to... It actually saved the... Even though I reinstalled PixInsight, it saved the settings from that last time. Nice. I set this one to multi-scale. Alright. Let's try it again. Even though this tool is not made for non-linear images, did this improve our situation? I think it did. Yes, I definitely did. It can be used for both. It's most powerful in linear images. I'm sorry. Another change that has the most impact on any nebula, but doing it too much can be very tempting, but it can really draw away attention from the agile, smooth, and clean, I say, nebulosity. Local histogram equalization, a tongue twister in and for itself. I will generate another preview because the main attraction right now is the nebula. There are ghosts in here. Create a mask. Yes, definitely. The settings from last time, all I did, the lower limit most of the nebula. Not everything. All the noise in the outside is not good. I'm sorry if you can hear the trains outside. I don't want this to take effect on the stars, that's why I will smooth this out to the maximum. Now the nebula is selected in the smoothest way possible. Apply. I like this mask. Let's put it on. And save it. Now, white selects, that is good, we want to work on the nebula. And usually these default settings are way too much in my opinion. I will increase the radius to 100, the limit is 1.5, so 50% more. And I usually turn the amount to... So I basically softened every single of these values. I will even go even further, go to 12-bit. Preview, apply. Let's see. And this shouldn't take too long, on the preview at least. Let's see. On the it can remove some nebulosity of the Pleiades, but as you can see, it's doing a pretty nice job of making the main stars a bit smaller and create more contrast. And I really like this change. I hope it's not too drastic on the main image. And I think this can take quite some time now. It's taking way too long. That's why I did not use the deconvolution, because deconvolution takes way longer than this one. Let's compare. Hello? As you can see, it softened the area around the very stars, but it's way too drastic, as I said. I don't like this at all. Let's turn the amount down even more, maybe 120 now. Apply to the preview again. And maybe you can hear my PC running wild. This is a very... I think I built this 4 years ago, maybe 5 years ago now. 5 years ago it was a very powerful machine. It's a bit outdated now. It's got an i7 in there. Yes. Way better. Let's apply. It's got an i7 there and quite a good amount of RAM, but I still want to upgrade in the future. I don't know what to do. Either upgrade the equipment or the computer. But I think I will stick with the equipment. Let's skip this part. Alright, I think I like this change. Let's compare it. Looking at the nebula. It created more contrast around the bright stars. Not getting rid of that much soft nebulosity, it's still there. I think I like that one. Let's stick with that. The next step before the color saturation, TGV denoise. This noise reduction tool is usually better with non-linear images like this one. Let's soften some settings. The strength could be 4. less edge protection, otherwise it's gonna create artifacts. Let's increase the smoothness, actually, 2.5. Let's apply the mask. Which one was the mask? We don't want to work on the nebula. So let's invert this. Don't work on the nebula. Thank you very much. It will work on the stars now, so maybe we have to sharpen them again later. Or include them in this mask. Actually, that's a good idea. Or not include them in the mask, I'm sorry. Well, no, never mind. Maybe should have chosen a preview. Yes, I will abort this and choose a preview with background and nebula. And you can already see the wavelet layers at work. This part on here is way smoother than the nebula right here. But maybe we can even that out a bit more. It definitely did not even out. And I really see no change at all. I have to see if this makes a difference. I will. The changes over here are powers of 10. So I hope that this doesn't ruin everything right now. Gee. The background noise is gone, but so is everything else. Never mind. Let's stick with the default values. I think they work pretty good. This works. And usually people don't zoom in that much on the nebula itself. When I tend to look at astro images, maybe on Astrobin or Twitter, I don't zoom in on any of the interesting stuff. I only zoom in on the background. How did they manage the background? And I think this looks great. Let's apply. I've been sitting here for over 2 hours now. And I think I got the whole. I bought another SSD drive and saved it only for PixInsight. I got an Astro SSD now, and I think it speeds up the whole process a lot. I just realized that I did not save anything, the project, during any of this. Save your projects in the meantime. You can do that. Just save project, and if you hit bundle, it saves everything in one folder, which has the little PixInsight icon that you can always return to previous steps. And how does the background look? The stars are definitely smoothed out a tiny bit, the tiny ones. I really don't care. Let's do some more adjustments. The curves transformation tool, applying an S curve to darken the background and lift the nebula. And I will not forget this time. Let's not pull out the stars. And I will not forget this time. The mask is still there. I don't want any mask with this. Amazing. I hope the background is not too dark now. I wish. Are there any readout options? I really want to know how dark the background is. I don't know how this works. I never used that one before. This looks great, I think. The background is way darker. I'm sorry. Just hit my microphone. Let's increase some colors. Nice. Let's increase. I just realized the noise reduction did not apply to the main part over here. That's why the small stars here look quite incredible compared to the rest here. Just a tiny bit of star. Alright, let's do some selective color saturation. At first, nope. At first, nebula only. Come here, don't be afraid. Nebula only color saturation. Is this too much? I don't. Maybe. Give me more of that cyan touch. Less dark blue, more light blue. I think this is good. Alright, and now the first time using the star mask tool. The default values should be nice. I want to include the bright ones, especially this one over here in the chain. I think these settings are quite good. Usually you want to choose the star mask on a preview to speed up the process to create the best looking mask for your stars. But I hope that the default values are fine. I just increased the scale to include the big ones. The star mask can take quite some time. That's why you are willing to use the preview, and imagine this on the image twice as large, 4 times the resolution, the Heart Nebula I did, for example. This took way too long each time. Come on. Let's use a preview. Alright, I think this can work. And you can see the masking over here. Maybe it's not too drastic. Let's increase the threshold. But I can see even the small stars have the yellow tint that you want in a Pleiades image. At least, I think so. The best images of the Pleiades I've seen have beautiful blue cyan nebulosity, bright central stars, a big variance in stars on the outer edges, and the yellow tint in the smaller stars, which I would really like to preserve. This is worse. Increase the noise threshold even more, so the nebula is not included. How many smaller stars are in there? The big stars are fine. Turn down the smoothness. Increase this one. And imagine now that we would do every single step now to the main image. It will take way too much time. I think it got all of the important stars. And I will zoom in into this one. I really like to use the star masks. I really like to use the star masks for the star reduction at the end, which I spent way too much time on. But if you're using too much smoothness and noise threshold and too little noise threshold, you can end up with this. These 2 stars are definitely in this mask, not 2 definite separate objects. Can I find them here? I think those 2. I really think those 2, definitely. And you really want to separate them in the mask, because they will just morph into one if you use the morphological transformation, which looks awful. Creating good masks is really important in this step, really important, and of course very important in basically all the other steps. Come on, be good to me. Yes, I like this. Definitely like this. Let's do it to the whole image. See you in a bit. I think most of the stars are in there, maybe not the tiniest ones, but let's apply. What was I about to increase the color? Increase the color in the stars. So we now applied the mask to only work on the stars. Why did I include the bright stars? I'm an idiot. The bright stars are already saturated. Let's stick with this one anyways. Let's look at the chain. I like the chain. Definitely change, and I like it. Alright. And the last step is to do the final background adjustments. Maybe I can do a little bit more of a curve. Applying the curve now to the masked stars. Could be interesting. Even more. I hope I didn't ruin any data right now, did I? Oh yes, I did. Definitely did. Alright. Remove this mask, do a tiny bit more of a curve stretch to darken the background. Not blur out the stars anymore as I have to. Alright, I like the background, I like the nebulosity, I like the noise. I still have to work on my attitude about the noise around the stars, because look at this. But I really have no idea right now how to get the stars even better. And it will only get worse now using this tool. The morphological transformation is to make the stars smaller in your image. That's why you create the star mask and apply the tool to the stars only. I always select size of 5 and create a small star shape using this tool. I think the mask is still good. Let's apply this tool on most of the stars, even the big ones. I'm using an iteration of 1, amount of 1, the smallest, not the smallest amount you can do, but a pretty small amount. And the change in your image will be drastic. You look at this. Reducing the stars is quite a discussed step, but it's very powerful to lift your subject out of this sea of stars. The stars are not the main subjects, in my opinion. The nebula, look at this. Awesome. And the colors in the stars worked out way better than I hoped. Amazing. Can this work on the star mask? It changed nothing, alright. And now I want to work on the shapes even more. I now want the tiny stars to almost disappear, and I want to separate the medium-sized stars from the big and the small ones. That's why I will create another star mask, but I will exclude the big ones now. So I consider the big ones, of course, the cluster stars and even the size of the chain here. Turn down the scale. Only the smallest stars. To create more contrast in the size. I forgot. Quite a big noise threshold needed here. Nice. Wait, I think I'm actually applying this process to the masked image. I am. This could have been bad. But up to now I really like what I'm seeing. The Pleiades are such a rewarding subject. If you really manage to spend a lot of time, integration time in there, and you use dithering to get even more colors, this will look incredible. Let's apply the mask with the smallest stars. I really tend to get carried away working on the stars, but I think this step can really lift this image to its full extent. Transformation again on the small stars. Let's make them disappear even more. Incredible. I think the color saturation saturated some of the background over here. I think I will run the SCNR once again on this one, on this mask, on the inverted one. Get rid of some green cast. Right, it didn't really change much, but at least the side over here. This is of course not the image I posted, but I also like this one. The nebulosity is better. I really think so. It's noisier, but I don't think that's a problem. If we would have reduced the noise in this area, we also would have made the tiny stars and some of the nebulosity disappear, which I really don't like. This looks incredible. The background noise looks pretty well taken care of. The stars are tiny and tidy, let's say. Maybe a bit more color correction in the background, but in the zoomed out version this looks incredible. And I think this is it. This looks insane. I love it. Let's save this entire project with the masks as a bundle. I will call it Pleiades. I will call it Pleiades Tutorial. Save with everything attached, nothing to lose. Alright, the saving can take quite some time. You can see the console popping up in just a second. The biggest file in saving is of course the main image, but the masks are also really large. To reduce your project size, which can be multiple gigabytes, I think the 4-panel mosaic of the Hard Nebula, the project is about, I think, 50 gigabytes, which is insane. The main image, of course, in the masks. You can reduce the bit depth of the masks to 8-bit, it won't change anything, but it will reduce the project size significantly. And I think applying this on the SSD is also way better, because I think the saving right now, as you can see, why am I pointing at the screen? The saving, as you can see in the bottom right, goes pretty darn fast in my opinion. And the last step now will be to make a profile transformation. I hope I'm doing this correctly. I only read it in a book once. I will remove the mask, create a copy, apply the profile transformation to it, and now we can save this one as our final image. In the past I used to save these images as JPEGs, but I tried to compare to the PNG files, and I really like the PNG files more. Sorry, microphone. Let's save it as a PNG on my desktop. call it app tutorial. Save. Come on, shouldn't take that long. Right. I can now close PixInsight. Now look at this. Doesn't this look incredible? I think let's look at the final image and see what I could have done better. Always an important step in processing. Would I release this version if I would have done this right now? I maybe contemplating this for a week will result in the saturation of the nebula is too much. Could have done a better job there. The noise looks amazing, the stars look amazing. The color on the bottom right in the medium-sized stars over here is maybe a bit too much, but not too bad. The background colors look good, it's dark enough. I really like this version. Alright, let's go back to PixInsight again and increase this one. I really hope you enjoyed this tutorial going through APP and PixInsight. If you are getting serious about astrophotography and editing, I really recommend getting at least APP. It can do an amazing job and will do many things way easier than stacking and editing. But editing in PixInsight is really, I think, the most powerful way there is. The imaging data of this particular image is available to everybody in the description. If you want more of my imaging data, I share everything, almost every project I make on Patreon, so if you want to support the channel, go follow me there and hit up any amount you really like. I really don't care if it's a small amount. If it's anything, I really love it because I can do much more with this hobby that way. Alright. Go ahead, download the data, edit this image the way you like. I will allow you to upload it to Instagram, your version, if you want to, and share it to me on Twitter, Instagram. I don't have Facebook. I don't like Facebook. Share it with me and tag me in anything. I will look at it and I will love it. My name is Tim. I'm an astro addict. I wish you clear skies and may the night be with us.